So we're jumping headfirst into this age of autonomous everything, right? We've got self-driving cars, automated factories, you name it. But behind all that cool tech is a massive challenge, one that engineers have been banging their heads against for decades.
I mean, think about it. It's one thing to get a single robot to do a task. But what if you have a whole team? A drone in the sky, a rover on the ground, a submarine in the water, and they all have to coordinate on one single mission. How in the world do you get them to communicate and, adapt when things go wrong?
For the longest time, the only answer was to program every single step. It was like a perfectly choreographed but super rigid dance. And yeah, that worked okay in a lab. But in the real world, it was incredibly brittle. If just one robot hit a snag, if one little thing went off script, the entire team could just grind to a halt. The whole mission, poof, gone.
But that's all starting to change. A new technology is ripping up that old playbook and starting fresh. Of course, we're talking about generative AI. And it's giving these robot teams something they have never, ever had before, a brain. A brain that can actually think and reason on its own.
So what this does is add a cognitive layer. That's the key phrase here. Instead of just running lines of code, generative AI gives these robots a huge database of common sense knowledge about how the world works. This means you can give them instructions in plain English and, this is the really crucial part, they can fill in the blanks when you don't spell everything out for them.
Okay, so how does this really work when the rubber meets the road? Well, researchers are coming up with some seriously cool new strategies. We're going to dive into 3 of the biggest game-changing approaches that are popping up right now.
All right, first up is what I like to call the AI conductor. The idea is simple. You have one big, powerful AI that acts as the central brain for the whole team. You give it the high-level goal, and it figures out all the nitty-gritty details, just like a conductor leading an orchestra.
Check out this example from a project called SMART-LLM. Researchers just told the AI, close the laptop and watch TV in a dimly lit room. Now, the AI didn't just tell a robot to close the laptop and another to turn on the TV. It used its common sense to figure out that to get a dimly lit room, you probably need to turn off the lights. A traditional scripted system would have totally missed that. It's that kind of inference that's a total game changer. So the AI conductor's process is pretty methodical. First, it takes that big, abstract goal and breaks it down into smaller, manageable chunks. Then it looks at all the robots it has available, figures out which one is right for each job, and starts forming teams. And finally, it spits out the exact actionable code that each robot needs to get its part of the job done.
Now, the second method flips that idea on its head. Instead of one conductor, what if every single musician in the orchestra had their own brain and could talk to each other to coordinate? Well, that's the whole idea behind the AI Team Chat. It's a decentralized model where every robot gets its own AI, letting them just chat to figure things out together.
And this leads to some absolutely wild emergent behavior. There was this famous simulation out of Stanford where they created a little virtual town with 25 of these AI agents. Get this, one of the agents just decided on its own to throw a Valentine's Day party. And what happened next wasn't programmed at all. The agents just started talking to each other, sending invitations, asking each other on dates, and coordinating their schedules so they could all show up to the party. That is complex teamwork just emerging from the ground up. Incredible.
Okay, this third method is all about how we, the humans, interact with these robots. It uses AI to build this seamless bridge between a person and a huge team of robots, what we call a swarm. The whole point is to get rid of complicated programming so you can just talk to the robots like you'd talk to a person.
And this is where things start to feel like they're straight out of science fiction. There's a system called LGPF, where a user can literally just say something like, have the drone swarm form the shape of a tree. The AI taps into its knowledge of what a tree looks like, generates the coordinates for every single drone, and then a whole other learning system guides them into that shape, all while making sure they don't crash into each other. Just think about the insane level of complexity being managed by that one simple sentence. It's mind-blowing.
So we've got these incredible new ways of doing things. But how do they really stack up against the old, rigid, rule-based systems? Because this is a really fundamental shift, and it comes with some pretty important trade-offs you need to understand.
From a bird's eye view, the difference is night and day. On one hand, you've got generative AI, which is all about being flexible, adaptive, and understanding plain old human language. And on the other hand, you have the traditional methods, which are efficient, sure, but they're incredibly rigid and brittle. They rely on fixed rules, and the second they face something they weren't programmed for, they just break.
But let's dig a little deeper, because the details here are fascinating. Take a look at optimality. A classic algorithm can crunch the numbers and find the one single, mathematically perfect solution to a problem. The AI's solution? It's more likely to be good enough. It's a practical, effective plan that works, even if it's not technically perfect. Or look at robustness. The AI can improvise when things go sideways, while the old methods just fail. The trade-off, of course, is that AI takes a ton of computing power, and, for now at least, it's a lot less predictable.
This tech is obviously revolutionary, but let's be real, we're not living in the Jetsons just yet. There are still some major hurdles we need to clear before we start seeing these AI-led robot teams everywhere.
And the biggest challenge really boils down to one word: trust. Right? We've all heard about AIs hallucinating or just making stuff up. If that happens in a chatbot, it's annoying. But if it happens in a robot that's controlling heavy machinery or a swarm of drones in the sky, that could be a catastrophe. So making these systems safe, reliable, and predictable is the #1 problem that researchers are focused on solving.
But don't let that fool you. The ambition here is just breathtaking. We are not thinking small scale. Projects like AgentSociety are already running simulations with more than 10,000 AI agents to try and model complex societies. They are tackling the problem of scale head-on, trying to figure out how to make these massive digital communities work.
So, what's the big picture here? We're watching a fundamental change from programming robots to actually collaborating with them. The old playbook of writing rigid scripts is being thrown out, replaced by these flexible, reasoning partners that we can direct and coordinate with. And that brings us to the biggest question of all. As these robot teams get better and better at thinking for themselves, what does our role become? What do we do?